Hey guys, my name is Nolan. On this tutorial, we're going to be looking at two types of smart contract factories. Basically, a smart contract factory is a smart contract that deploys other smart contracts. We're going to be looking at the standard method of doing this and the cloning method of doing this. We're also going to be talking about some pros and cons of each method and why you may want to choose one or the other. For this project, we're going to be using Truffle, Solidity, Web3.js, and Ganache. We're going to be writing a simple test for it, and we're going to also talk about briefly just a couple of use cases that this might be used for. So without further ado, enjoy the tutorial. Thanks. All right, so let's get started. So the first step is you have to open up a terminal. And I have a terminal here, and I'm located in a folder called Truffle, which is where I keep some of my projects. And the next step is to create a folder within this folder, which will be the one that actually has this specific project in it. So to do that, we'll do mkdir, which stands for make directory. And we'll give it a name. Call it factories. And then we'll do cd factories, which is change directory to factories. All right, so at this point, we're ready to actually get our project started, but we have to make sure that we have all of the dependencies installed. So if you've done some tutorials already, you'll probably have this step already completed, but to check, we can do truffle version, hit enter. And if this comes up, then you have everything installed. If not, then you have to do a few things first. So first, let's install Truffle. You can find that here, trufflesuite.com. And it's actually a very easy. You can just copy this command right here. Before that, though, if you don't have Node installed, you have to install Node. And you can get that here, node.js.dev, install Node. Next. So Solidity and Web3, I believe, come with Truffle, so that's good. And then the blockchain we'll be using is called Ganache, and you can find that here, trufflesuite.com as well, /Ganache, download it right here. And that will be the local blockchain that we'll be using for this project. So once all those are installed, we're ready to get started. And so the first step is you can do truffle init. And this is going to initialize a truffle project within this folder. And if we want to check the contents, you can hit ls and we'll see what's inside. So we have a contracts folder, migrations, tests, and a config file. So next step is actually npm init. And this is going to get Node set up in our folder. And that's important for installing different packages that we'll be using. So once you hit npm init, we'll have some instructions to follow, and normally I'll just hit enter through these. And then if you hit ls again, we'll see we have a package.json file, which is perfect. And then at this point, we're ready to open it up in our code editor. And I use VS Code. You can use whatever you like. I believe with VS Code, it comes standard with a command, and it is code space period. And this is going to open up the code editor in this file, in this folder. So hit enter. Cool. So just hit code space period, and we're greeted with this screen right here. And on this side, we'll see all the folders that we saw over here. So it's the exact same thing. So here, migrations.sol comes with Truffle. So you'll see this as well in your project. Migrations, this is a script to deploy our contracts. And we'll be adding another one here in a little bit. Tests, obviously this is where our tests go, and right now it's empty, but we'll add a test here in a little bit. Config file, this is all the settings I will be using, and actually at this point we can just go ahead and clean it up a little bit. We'll get rid of some of these comments. We'll keep this one. We'll uncomment that, and on Max, uncomment is command and question mark. and then we'll just delete this. We'll keep this line actually, and we'll change it to 0.8.6. Then we'll delete this and that. All right, we'll hit save. Cool. Now let's go ahead and make the files that we'll be using. And like I said in the intro, the whole purpose of this project is to look at two types of contract factories that we can make within Solidity. The first one is a basic standard version, and we'll be comparing that to the cloning method, and we'll see some differences and some benefits of cloning. So let's do that right now. We'll make 4 files in total. So the first one will be standard factory .sol. Second one will be token. This is going to be the ERC20 token that we're going to be deploying with our standard factory. And then we'll do cloning factory. And then we'll do cloning token. So in both cases, we're going to be deploying a very basic ERC20 token. Cool. So let's get started with the first token. So we'll say pragma solidity, and we'll do 0.8.6 like we set up in our config file. We'll name our contract, give us some room, and then so we're going to be using the OpenZeppelin library pretty much in all of our contracts. OpenZeppelin is super useful, and it's basically considered industry standard at this point. The contracts are very well audited, safe, and secure. So before we can actually import anything, we have to install it. So we can do that via npm, and we can do that in our terminal here. However, I like to use the built-in terminal in VS Code. So we go to terminal, new terminal, and then it opens up one in this folder, which is identical to this one. Cool. So to install it, we can do npm I at openzeppelin/contracts. Hit enter. And if you're unsure, you can always check out npmjs.com and look for OpenZeppelin contracts. This is one we'll be using later, this upgradable one. We'll get back to that. Okay, yeah, there it is. So yeah, OpenZeppelin/contracts. And then it gives you the command right here that we can copy and paste. It should be the same exact one that I put in here. And if that goes through, you'll see it creates a node modules folder, and it has OpenZeppelin in there, which is what we want. As well, you can check out package.json, and you should see under dependencies OpenZeppelin contracts. That's perfect. So now we're ready to import it. So to do that, we'll say import, and then how you import is you basically just copy the exact path that the contract is in that we want to use. So in this case, it's OpenZeppelin contracts token ERC20 and ERC20.sol. So we'll copy that exactly, and it looks like this. Cool, and I made an error right here. All right, so that should be good. And then the next step is to actually tell our contract that we're going to be using this one and that we want to import all of these functions into ours. So to do that, we'll do space. It'll look like contract token is ERC20, and that's just the name of the contract that we'll be inheriting from. Cool. So the next step is we can set up a constructor function. And we have an error right here, and that is because ERC20 has its own constructor that we need to reference, and this takes a name and a symbol parameter, so we have to include those as well. And the way we do that is we do a space ERC20, and then we input our parameters. So in this case, the name will be token and the symbol will be TKN. All right, that's awesome. And then what we want to do is we want to mint a little bit of tokens so that we can test it and make sure everything works. So to do that, we'll be calling this function right here, mint. So we'll copy that, and this takes an account and an amount, and basically this function mints amount of tokens to account. So we'll do that here, and then for the account that we'll be minting to, we'll put that as a parameter in our constructor, which we can specify when we deploy it. So we'll say address recipient, and then we can put recipient right here, and then the amount. So we want to do, let's say, 1,000,000 tokens. So we can say 1,000,000, and then we have to specify the number of decimals that one token can be broken up into. So in this case, we'll be doing 18, which is the standard. That's what ETH is denominated in. So to do that, we can do times 10 times power of 18. Cool. And that should be good, actually. So this is the very, very basic ERC20 token that is perfect for this example. So now we can actually make the contract that's going to deploy that token. So same thing, we do pragma solidity 0.8.6. Then we can do contract, give it a name, which is just the same name as the file name. All right. So since we're deploying this token right here, we need to import it. And we do, and yeah, so since token is in the same folder, we just do it like this. Done. So we need to give this a constructor as well, and we'll flesh it out in a second. And then the actual function that's going to deploy this contract, we'll name it factory. And we'll make this function public, meaning it's visible from outside of this contract, which is what we need. We'll do this right here. And then the very most basic form of this is we can say like something like this, new token. And so this is all we need. This will deploy, wait. Oh, my bad. I forgot this address. So yeah, so we have to specify an address in here. And we'll copy that and put it in here. So now there shouldn't be any errors. Cool. So yeah, this is the most basic form. This function, every time you call it, will deploy a token. But we want to do a few extra things so that we can actually get the address of this token from outside, specifically in our tests, but you also want to do this if you're making a front end, for example. So to do that, we want to wrap this in an address, and then we want to set it equal to a variable. So we'll say address token equals that. Cool. So this is what it's saying is there's a address named token, or a variable named token, and is of address type. And then this function, or this line right here, actually creates an instance of token that is deployed, and then this part just grabs the address of that token and then sets it to here. So that's good, but at this point we can't see this variable. So the way we're going to fix that is we're going to get an event and name it token deployed, and then we'll pass in an address. We'll call it token address. And then down here, we'll emit that event. Yeah. Wait, that was wrong. And then we'll say token right here. Cool. So at this point, when this is emitted, we'll be able to grab that address from outside of Solidity, and we'll be able to use it. So another thing we're going to want to do actually is we're going to want to restrict who can call this function. So to do that, we can use another OpenZeppelin contract, which is ownable, which is under the access, and it's called ownable.sol. And this gives us a modifier called onlyOwner, which requires that only the owner can call the function that is that has this modifier, and the owner is set in the constructor. So it is the message sender, which is the person who deploys the factory. So to use that functionality, we'll do import space OpenZeppelin contracts access ownable.sol. Cool. And then to inherit it, we have to do is ownable. And then to use that modifier, we can do only owner. And that should be good. And then one more thing we'll do is we'll give this contract a name. So we'll say string public name, and then we'll set the name down here. So we'll say name equals standard factory. All right, so this should work. This is a very basic factory implementation. It doesn't have too many functions, but it's enough for this purpose. So at this point, we'll save that, and then let's do some cloning stuff right now. So let's make the token first. We'll say pragma again, solidity 0.8.6 contract cloning token. Cool. And so at this point, we're going to be using OpenZeppelin again, but it's a slightly different set of contracts that we'll be using. And they have another library called OpenZeppelin contracts-upgradable, which is what we'll be doing. So you install that pretty much the same way. We can head back to npm. You can say OpenZeppelin contract, or right here, contracts-upgradable. Awesome. We can grab this command right here. Come back to this. Paste it. Hit enter. And then we should be seeing, let's see. All right, sometimes it doesn't update right away, but it's in there. So we'll import it, and I'll show you how to do that. So it's another ERC20 token, but it's slightly different. Say OpenZeppelin, oops, /contracts -upgradable /token /ERC20 ERC20 upgradable. Okay, what did that do? There, contracts. Cool. So again, we'll say is ERC20 upgradable. Let's see if I just run this one more time. Let's see if it'll show up here. No. But yeah, here it is. So we know we have it. We can't see it right now. Oh well. So the difference, the main difference between these upgradable contracts is that they don't have constructor functions. Instead, they have a normal function that's called, usually called initialize, and it basically does the same function. It does the same thing as constructors, but it's not run automatically on deployment. Rather, it's usually used through the factory factory pattern. And so in the cloning factory, like this one, we'll have a function that deploys it, and then within this function, we'll deploy it in one line. Then the very next line, we'll call the initialize function. That way, if, for example, in our cloning factory, which we'll write right here, if there was two functions, one deployed it, one initialized it, two separate functions, then that means there'll be a time difference, and there'll be a period of time where a token that we deploy is uninitialized, and that is a security vulnerability. So we don't want to do that. Instead, we want to have it. We want to deploy it and initialize it atomically, meaning either both go through at the same time or none of them do. So I'll show you how to do that. But yeah, so the cloning token is very simple. So we have this one so far, and we're actually going to make a function called initialize. It will be public. And then this function, or this contract right here, gives us... Okay, so I went ahead and actually closed this project and reopened it, and here we go. We have the contracts upgradable, so I'll be able to show you what I mean now. So if we go to ERC20, we see this function right here, and this is basically acting as the constructor. You'll notice it takes the same parameters, does the same thing as the constructor, and as it also imports the initializable contract, which is another OpenZep1 contract, and it gives us some handy functions that help us initialize our contracts very safely. One of those things is the only initializing function, or modifier rather. And what that means is that this function can only be called by another function that has initializer modifier on there. So this one is going to have the initializer modifier. So only this function right here can call this function to set up the contract. So that makes it much more safe, and that's what we want to do. So yeah, and since this contract inherits from initializable, we have access to that in here, so we don't have to import anything extra. So we'll say initializer. Cool. Okay, we'll come back to this error. I think it should be fine. Okay, so that's what we want so far. So this is the initialize function, and this will basically does the same thing as a constructor. And then within this function, we want to call this one. So we'll copy that, and remember we have to give it a name and a symbol. So the name will be cloning token. We'll do one word. Symbol, let's say CTN or C. Yeah. Awesome. And then same kind of thing, we want to mint some, so we'll say address recipient, and then we'll get the mint function, which is underscore mint. We'll give it recipient. And the same amount, we'll do 1,000,000. So that's it. That's what our cloning token looks like. All right, fixed it. So if you get this error, you can just go in here and change the global compiler version, and that should work. All right, so once we got the cloning token done, we can actually make our factory now. So we'll do the same thing, pragma solidity 0.8.6. And we'll name our contract. Awesome. So again, like our standard factory, we need to import the cloning token. Done. And since this is a cloning factory, we actually have to import the cloning logic. And that can be found in Open Zeppelin right here. It's under proxy and clones. So that's what we want. So contracts, proxy, clones.sol. All right. So this one does take a constructor, and we'll basically you do the same as a standard factory and just name our contract within the constructor, but we'll get back to that. Next, we'll do function. We'll name it clone. And so within here, what we'll be doing is we'll use a function from clones from this contract here. So clones.clone, and it looks like this one right here. And then we pass an address of the implementation, which is basically the logic of the token or the contract that we're cloning. So first we have to get that logic. So the way we do that is we basically deploy a blank contract of the cloning token, but we don't initialize it. And this one's not actually being used by, for example, if we had a protocol that we were deploying or making a factory for, we won't be using this token. This will just be a reference of all the functions and the logic that the tokens will be using. So the way we do that is actually very similar to this way, pretty much identical actually. So we'll say new cloning token, and we want to save that as an address again. And then up here we'll make a variable called address public token implementation. Oops. Let me make sure I spelled that correctly. Yeah. Cool. There we go. And then we'll say token implementation equals this. Awesome. And then in here, in our clones, we can pass the token implementation. Cool. So yeah, we'll give this a public visibility, and then we'll add only owner to that in a second. But now, if you'll recall, we'll have to call the initialize function. And like I said, we're going to do this in the exact same function, as opposed to like two separate ones, for example. So here we'll do address token. So we have the address of the cloned token that we'll be using, and then down here we can say cloning token. So we're pointing this contract to the address that was just created. And then we can call functions of this from this contract. So we'll say initialize. And yeah, we'll give it the recipient, and then we'll just create a recipient right here. That should be good. So that's it. Let's go ahead and do only owner. What did I do wrong? Oh, my bad. Ownable. And we'll say only owner. Cool. So yeah, so basically this is just going to call this function right here, which will in turn set up everything that we need in our contract, which is just the name and the symbol in this case, and then it's going to mint. So that's perfect. Let's do the event as well. So say event token deployed. Cool. And then we'll go ahead and emit that event. And we'll pass it the token, which is this one. All right, awesome. Lastly, just for consistency, we'll do string. We'll give it a name. And we'll set this name right here. All right, looks good. So now we're done. So all our smart contracts are actually written. We have no obvious errors right now, which is good. The next thing we can do is actually compile it. So let's try that. Let's do truffle compile and just make sure nothing bad happens. All right, so we should be seeing this message right here, and that is what we want. So everything's good, no errors, and that's amazing. Next, we can actually deploy it to Ganache, which is our development blockchain. But first, we have to set it up slightly. So I'm going to open up. Yeah, I'm actually going to just X out of that. Then we'll open it up again so I can show you how to set it up. So we're opening Ganache. It might take a moment. When that opens up, we'll see this screen right here. We'll hit quick start. Cool. So this is what you should be seeing when you open it up. It gives us 10 accounts with 100 fake ether already in them, so that we can use. And the first one in our list is used by default by Truffle, and this will be our deployer. And in turn, this will be the owner as well. So that's something to just be aware of. And then the next thing we want to check out is the RPC server. So we see this link right here, 127.0.0.1.7545. And then if we go back to our Truffle config file, and if we check out the development network, we'll see the same number here, but we'll see 8545, and we want to switch that to 7545. And then once that is changed, everything should be good for now. So now the next step in deployment is to create our deploy script, and it's going to look a lot like this one right here. So what we'll do is we'll copy and paste it in the same folder. Then we'll rename the one we just pasted. We'll do 2_, deploy underscore contracts. Enter. Cool. So in the initial migrations, this is deploying this contract right here. So we just need to actually switch this name to the ones we want to deploy, but we'll use the second one that we copied. So for example, we'll do standard factory here. And then we'll copy this here and here. And then we also want to do cloning factory. So we'll copy that line, go down here, we'll do cloning factory, which is the name of our other one. And we'll copy that here. And then we need to copy this as well. Done. So that should be good. That should deploy our contracts. And let's actually give it a test right now. We'll do truffle deploy. Looks like it's working. Awesome. Cool. Everything is good. It's amazing. So if we go back to Ganache, we'll see that we use some of our ether. And it's from the first account, which is what we expected. And this is what we want to see. So this means that truffle is successfully connected to this development blockchain. And that's awesome. So the next step is testing. And this is a very critical step that is a good habit to have. So to get started, we'll say new file. We'll say factories underscore test.js. So the first step is to just bring in instances of these two factories right here that we want to test. So we'll say const standard factory equals artifacts dot require, and then standard factory. Awesome. And then we'll do the same thing for cloning factory. Sweet. Cool. The next step is we need to install a few more packages, node packages, that we're going to be using for testing. So the two things we need are chai and Ethereum waffle, which we can check this out here, chai. So chai is an assertion library for Node, and this is what we want. This gives us some handy functions to use. So we'll copy this, come back here, paste it, and then we'll grab Ethereum dash waffle. Which is this one right here. And yeah, this is what we want. Most advanced framework for testing smart contracts. Sounds great. So we'll copy that, paste it, install. And then the next step in our tests is to actually pull in these packages so that we can use them. So for Ethereum waffle, there's a section called solidity. I'm not sure if it's in here or not. Yeah, we have to basically do this right here, or this part. So we'll say const solidity equals require Ethereum waffle. And then we'll do const chai equals require chai. and then we'll do const expect, which comes from chai, equals chai dot expect. And then we want to use we want chai to use solidity. So to do that is just chai dot use solidity. Awesome. So now we're ready to actually get our tests started. After this installs. Well, I should type this correctly as well. All right. So to organize our test, we're going to say contract factories in quotes. And then in this part, well, this is wrong. In this part, it lets us get an array of addresses that we'll be using, which correspond to these right here. So the first one by default is the deployer, and then user 1 and user 2. All right, then we'll do an arrow. Cool. So this is where our entire test is going to be located. So let's go ahead and actually get some deployed contracts in here. So we'll name some variables that at the very top so that we can keep using them. So we'll say cloning factory, standard factory. And we'll say before. Give it an async function. We'll say cloning factory equals cloning factory dot deployed, and we'll do the same thing for standard. Well, we want lowercase here, equals standard dot deployed. Cool. So let's make sure that these two contracts have proper addresses. So let's say it, okay, not that, it has proper addresses. We just need a function here, and we'll say expect cloning factory dot address 2 dot b dot proper address, and this is a built-in function given to us by Ethereum Waffle. We'll do that same thing for standard factory dot address dot 2 dot b dot proper address. Let's give that a try right now just to make sure. We'll do truffle test. Don't need that. Let me see. Okay, I got it. Oh, wait. Okay, perfect. So it works. So these two contracts both are deployed and both have proper addresses. So let's check if it has a name, and that's why we put the name in there, just so we can make sure that it is accurate. We need this to be asynchronous. So we'll say expect. We'll do await. We'll start with cloning factory dot name 2 dot equal our name. So let's see what we named it. Let's copy this. So the reason we can actually call this function here is that we named or we made this variable public, and that gives us a free function that lets us just return the value of this variable. That's really handy. And then we'll do the same down here for the standard token. Standard factory, I mean. And I just like to copy it, so I'm sure I didn't do any typos. Oops. There. Let's give that a try. Awesome. So the name is correct as well. So at this point, we can be pretty confident that it deploys and everything's good. So that's awesome. Now we can move on to the main part, which is we're going to test the token deployment functions. So we'll organize this in a describe block. So we'll say describe token deployment. And in our before, we'll do this, and in this part is where we will actually deploy them. And we want to just get some variables here. So in Web3, these functions, or when you call public functions, or any function rather, it gives us a receipt, which basically has all the information from that transaction. So we'll just name those right here. So cloning receipt, maybe lowercase, and standard receipt. Oops. Oops. And then we'll say cloning receipt. Equals await. And then we'll grab the cloning factory here, dot clone, I believe we called it, and we need to pass in an address, so we'll say deployer, and that's it. We'll do the same down here. Await standard factory dot factory, and same thing, we'll give it to the deployer. So this deployer is going to be this guy right here, the recipient of the tokens that are minted in the constructor of this token, and same for here. Cool. So at this point, we can check if those have proper addresses. So tokens have proper addresses. So just to demonstrate, let's just console log one of these receipts so we can see what's in there. Awesome. So this is everything that we're given in the receipt right here. So this has everything we need pretty much. So you can see it has an event keyword here, and this is the event that is emitted by this transaction. And so this one is what's going to have our token address. So to get to it, we do the receipt dot logs index 0, I think specifically, the arguments, and then the name of the argument. So it looks like this. And we named it token address. I'll show you right here. So we have to make sure that's that. Let's try this. And you'll also notice really quick, gas used. So this is important. I'm going to come back to this. I'll show you why in a second. Awesome. So yeah, it just gives us an address. So this is the address of the token that is deployed by the factory, the cloning factory. So that's great. And now we can say expect to.b.proper address. So this should pass, and then we'll do it again for the standard receipt, and this should pass as well. Let's double check. For some reason I think this is wrong. I'm going to fix that. There, bugging me. Awesome. So the tokens both have proper addresses, and that is exactly what we want. So that's great. So at this point, we're going to revisit that gas used thing. So we'll say track gas used. And the reason I want to show you this is reason number one of why cloning is sometimes a better idea if you're going to be deploying lots of lots of contracts. For example, like Uniswap or any decentralized exchange, each token pool is its own contract. And there's a lot of pools out there. And so that adds up if deploying one each time costs a lot of gas. So we'll see that cloning is a bit more efficient than the standard method, a bit cheaper as well. So let's do that right now. So let's scroll back up, check out the receipt. So the cloning receipt dot receipt dot gas used. Let's see if that returns the correct value. So let's just get the cloning receipt. Oops. Dot receipt dot gas used. Let's see what that gets us. Awesome. So yeah, it returns this number that we saw up here, which is perfect. And then for visualization's sake, let's just console log this. We don't need to really test anything about it, but we'll just we want to see the numbers. So we'll say cloning gas used. And we'll grab the standard receipt and put it here. And we'll say standard factory. And then we'll use factory right here. And we don't need asynchronous here after all. Awesome. So yeah, let's check this out. So the cloning factory uses 185,000 gas, whereas standard factory to deploy a token, the same token, uses 1.1 million. So that is a huge difference and a lot of money difference as well. So that's one reason why this is important, and cloning is perhaps a better alternative than standard factories. Another use case could be like smart contract wallets, which are gaining in popularity, and generally the user pays for deploying their own contracts. So for a company that has designed a smart contract, it's in their best interest to make it as cheap and easy for the user to deploy. So they might want to use cloning, for example. So that's number one. And we'll visit reason number two after we get these tests finished up. So we got the addresses. Let's check the balance now. So it tracks balance. Cool. And in this case, we're going to call a function on the token itself, which we haven't done yet. So we have to do the same thing that we did here for our two tokens. So we'll do token, and then cloning token. Cloning token. Cool. So that's all we need to do for that part. And then here, we will actually create the instances of those contracts that we can then interact with. Let's do that up here. That might be a better idea. So we'll do let token and cloning token. So here we'll do token equals token dot at, and then we want to get this address. And then same thing for cloning token equals cloning token dot at here. So what this is saying is basically there's the instance of this token, and then we'll point it at this address, which we just deployed. So that should be good. And now, since it's in the before hook, we have access to it down here. So let's try it. Let's get the name. So let's say let name equals token dot name, and this is going to be await. Let's actually, you know what? Let's try this. Let's do expect await name token.name or 2.equal. I believe it was token is what we named it. Let's do that. And while we're here, let's do the other one. So cloning token should equal, let's double check, cloning token. Cool. Let's try it. Whoa, I just realized we said balance here. Let's do name first. Autopilot. All right, so we have an error. Let's try to figure this out. Of course, I always forget. Await. So now it should work. Awesome. So that works. Amazing. Now at this point, let's actually do the balance. So tracks balance. Cool. So let's do expect. We'll say await token dot balance of. We'll do the deployer because that's who we minted everything to. And we'll say .2.equal, and then here we'll do web3 .utils .2way, and then as a string we'll say 1 million. So what this does is this function actually gets us to the 18 decimal places, and it does it really carefully. So let's try that. Okay, really quick, we need to actually we can't do this right away here. So let's save this to a variable. Let's say let balance equals that, and then we'll do balance dot toString. So yeah, this should work. Sweet, so that works. And then we'll just flesh it out one more time. So we'll do both tokens. So this is the standard one. So let's say token balance, and then we'll do down here, we'll let cloning token balance equals weight cloning token dot balance of deployer. And then we'll basically copy this. We'll do cloning token balance, and then up here we have to do token balance. Let's try that. Oops, balance of course. All right, awesome. So both tokens mint the correct amount to the correct person, and they both return that amount when asked. So now let's try transferring. Transfers tokens. Cool. So let's grab an amount. So let amount equals, and we'll do the same thing here. We'll say web3.utils.toWay, and let's do 100 this time. So we're going to transfer 100 tokens. All right. So we'll do await token dot transfer, and then just to double check, let's go here. Transfer. So recipient and amount are the two arguments we need to have. So let's transfer it to user1 and amount. Awesome. And then we can do the same thing here. We can say let user1 balance equal await token dot balance of user1, and then we can say expect user1 balance 2 dot equal dot amount, and we have to say toString here. All right, let's try that. And we'll do the same thing for the other token as well, assuming this passes. And just a quick reminder, so by default, the caller of this function is the deployer, is #1 here. So that is just the default. And that's what we need. All right, awesome. So it works. So now we'll double this, basically this code right here, and we'll do both tokens. So cloning token dot transfer user1 amount. Cool. And we'll say standard balance, or no, token balance. And then we'll do the same thing pretty much. Clone balance, cloning token, which is the, let me see. Cool, yeah, cloning token. And then we basically need to copy this. So first, let's fix that. And that should be good. Let's try that. Awesome. It passes, so that's great. Just to be extra sure, let's add another little thing here. So yeah, let's get the deployer balance after transferring, just so we can be sure that it leaves his account. So let's say this is deployer token balance equals await token dot balance of deployer, and then we'll do the same thing for cloning. Great. And we'll do basically 2 of these as well. And then we'll change the amount. We'll say web3.utils.toWay, and then we'll basically figure out, so 1 million minus 100 would be let me see. So 900,900, is that right? I think that's good. Let's try that. Awesome. So it works. So this will probably actually conclude our testing for this project. Let's recap the test a little bit. So up here, we basically pulled in all the contracts that we want to perform tests on. This part right here, this this gives us all the tools we need to do the testing. And then this is our actual test right here. So first we test the deployer, the factories. We check the addresses, we check the names, we check if the function, the factory functions actually work, which they do. And now we make 2 instances of the tokens that we'll be using for the rest of the tests. So we check that tokens have proper addresses. We check, we just record how much gas was used to deploy them. We track the name, the balances, and we check if transferring works. And it all does, so that's great. Last but not least, I want to touch on one other thing. This is another benefit that I enjoy about cloning. So basically, it's it's the contract size. So these factories, these 2 things, let's assume that these are part of a bigger contract or a entire protocol or set of contracts, and so these add space to the contract, and there is a contract memory limit that you can't surpass. So we want to keep everything as small as possible while maintaining the same functionality. So we'll see in a second that cloning factory used up a lot less memory than standard factory. So let's check that out now. So there's a package we need. It's called Truffle Contract Sizer. I think it's called that. Here it is. Truffle contract size. So let's copy this and let's install it. And then we head back here. It gives us it tells us how to use it. So we have to copy this, and we'll throw this into our truffle config file, which is right here. So it's, as we can see, It's in the module exports, so it's right here. And we can just throw it anywhere. I'm gonna put it in the bottom, just like that. So add a comma right there, that's good. And then this is how you actually run the command. So for this, we're going to do truffle run contrast dash size dash dash contrast contracts dash dash contracts, and list the two that we want to actually measure the size of. So we want to do the two factories. So let's do that now. Let's say standard factory and cloning factory. Let's hit enter. Let's see what comes back. There we go. So as you can see, standard factory is a little less than 4 times larger. So that's big. That's a big deal. Cloning factory is super small, super efficient and compact and cheap. So those are 2 big reasons why someone might want to use the cloning method in their contracts. One side note, actually, so when deploying the factories itself, you'll notice that in the constructor, we deploy a token, and in the same way here. So the first step, the deploying of the factories themselves, will be slightly more expensive, or maybe a lot more expensive than deploying the standard factory. But assuming that your protocol or your set of contracts will be deploying lots of contracts, then that definitely is a payoff in the long run. So yeah, so let's just double check. Let me make sure I didn't forget anything here. I think I covered it. So yeah, the 2 main reasons, which is basically the whole point of making this video, is to show you that the cloning factory is way smaller than standard factory, as well as the actual function is way cheaper. So those are 2 big things that I wanted to just share with you guys. Let me see here. Yeah, I think I pretty much covered it. So just to recap on the whole thing, we looked at, so we made 4 smart contracts, 1 super basic token, 2 super basic tokens pretty much, but we looked at the initialize function, how it works, how it's pretty much the same as constructor, but it's not called automatically. Instead, it's called right below the actual cloning process. We saw just the basic standard factory, and yeah, so that's about it, actually. Hope you guys enjoyed. Hope you guys learned something, and thanks for watching. Bye-bye.